Good day, welcome back. I hope you are learning a lot from the previous sessions and you are getting familiarizing yourself with different concepts, with the different registers and how to use buses and where the bus is connected to which peripherals, etc. Welcome back. I warmly welcome you to day 11 on embedded system on ARM Cortex M4 series. We are in the intermediate part of this M4 series, so I'm going to just give you a short recap of what's ahead for the next 10 days. Day 11, we'll be learning about understanding about the startup file. Day 12, you will learn about understanding how linker scripts is and how it works. In day 13, you're going to learn about fault handling and analysis. Day 14 and 15, you're going to learn about UART. Day 16, you're going to learn about interrupt programming. Day 17, you're going to learn about system tick timer. And day 18 and 19, you're going to learn about implementation of task scheduler. Then we get into the interesting advanced chart. So I'll start from here. You're going to learn how ADC and what is ADC, how ADC works. So let's get in. Today is day 11 and you'll be learning about startup file and get to know about what it is startup file is. In today's sections, this is what you will learn. You're going to learn about a tool chain installation where you understand about the startup file and you're going to download a GNU tool. If I'm sure you have already downloaded STM32CubeIDE by now. That STM32CubeIDE will have the default GNU compiler, GNU tool. If not, you can download that separately. The GNU compiling tool, the tool is a binary file. You won't get the graphical representation interfaced in there. You have to run everything through the command prompt. You can't use the general IDE. So you're going to learn again how to compile a C program without using an IDE and learn about different sections in the IDE, but in a much more detailed version about what each and every section represent. And also you're going to learn what is a startup file and how these sections are placed inside the microcontroller memory. And also you're going to write your own startup file and you will understand how it works. Also you will get to learn to write your own startup code, and this will explain the default startup file, how it all used, and also I'm going to show you how the STM32 generates the startup file, and I'm going to go through with you about the startup file created by it. I hope by the end of the session you have a familiar and much more in-depth understanding about startup file. It is one of the important file that you use in the embedded system programming and the embedded system design. So pay much more focused attention to this, and it's very easy and you will learn by the end of it, and you will know how to place this in the microcontroller memory in both flash and SRAM. So let's get in and see what it is. Before jumping in, a small introduction about whom I am representing. I'm representing A2DG. As you can see, it's a startup by Anbukarasu brothers, my brother Alex and myself Arul in 2023. Both of us gathered over 20 years of experience in the industry, and we both would really like to share our knowledge and experience to you all so that you can also be futuring into a successful, a bright and a fruitful professional engineer. And if you'd like to learn about website design and development, please also stay tuned with A2DG, and my brother will handle that, and he has years of experience, so you are in good hands and he will be able to teach you right from scratch up to completion. And our mission is to convey knowledge and our experience to at least 100,000 future professionals through online courses. The main advantage is you can study at your own pace, at your own time, wherever you are. So that is really good about it. A little bit about me. I am Arul Prakash Anbukarasu. You can call me as Arul or APA, as popularly as I would like to be. Sorry, I rubbish this on your face all the time. I can't help myself. I have 20 plus years of experience in various industries in Australia, working in major industries starting from renewable energy sector that concentrates on solar energy and wind energy, power systems in lead acid batteries, network embedded systems that involve ATMs, TCRs and POS, banking automation systems, smart parking operations, and my major expertise is on these three: embedded systems, VLSI and project management. I have a small announcement to make. I have categorized into two different categories. One is the YouTube viewers and internship professionals. All the video sessions that I'm teaching you will be uploaded into my YouTube channel on A2Digi. To be eligible to get a free certificate, you have to attend at least 28 classes. At the end of every video, there will be an attendance link. I would like you to fill in your details so that I can get that, and if you successfully do 28 days, then you'll get a free certificate. But part of the YouTube regulations, the videos can't live there forever, so it has to be removed after 2 or 3 days. So if you miss a day, if you want to revise, you can't go back, unfortunately, to do a revision. That's why I strongly recommend you and advise you to join into our internship program. What would the internship professionals will get up to? They will acquire an internship certificate, and the internship certificate is worth a lot. Imagine you have landed on your first job and you're working with other engineers who are already in the industry, or you're hitting that interview and you are in the interview and you're faced with a lot of questions. They know, the senior engineers and the product managers, they know how valuable this is, that you spend these 30 days to learn this microcontroller, and that is worth a lot. So please invest on your self investment. So please go ahead and purchase and join our internship program. Not only that, you also get your own self login to log into our learning management system portal, and you can go through our everyday session. And once you finish one session, and when you hit on complete and continue, that counts as the attendance for that day. And also on top of all of this, you get unlimited access to all the course contents, all the PDF materials, all the source codes, all the other reference manuals, and all those kind of necessary documents that you want to do. And also you get unlimited access to watch the course contents. That means you can pause, you can come back and rewatch it again, or you can rewind or forward. So it's all yours and you can do it. And also, if you get stuck anywhere in learning process, please contact our backend support team, and they would be able to assist you to make you move along with the course. So these are all the materials required. Please do contact Pantech Solutions, and they are a big manufacturing company, and they would be able to help you to acquire all of this. The more you have your hands-on practice, the more experience and more knowledge you would gain, and that would really help you to shape into a better professional engineer of you. So please make an investment right now if you haven't already bought. So please contact Pantech Solutions and buy this. I'm sure these materials you can use for your own project as well. So it's not only you can use only for this learning in the next 30 days, but you can come up with your own project and you can use all of these materials in there. And these are all the documents that would help you for you to do your learning, and will assist you to make you understand clearly with the concepts. You need the STM32F411 datasheet, you need the STM32F411 reference manual, you need the Cortex reference manual, and the IAPC standard procedure called standard for the ARM architecture. If you haven't already, please download this and keep this handy so you can go through it. You can also refer to the Facebook group. I have loaded all these documents there, and you can download it from there. or you can directly go to STM32 website and you can download all of this. I'm sure you are keen like me to get in to learn. So imagine like this pyramid. So you slowly gain your experience, and main goal is to reach the pinnacle on the top, and by then you would have plenty of experience. So let's be like this and let's get in and learn. Okay, first of all, we're going to cover what's cross compilation. If you cast your mind back, you might have heard this word and you know a little bit more about from day 3 about cross compilation. So what is cross compilation? Cross compilation is a process in which the cross toolchain runs on the host machine and creates executable files on the other machine. That means it creates executable files so that it can be sent to a embedded target. In this case, the embedded target we are using is STM32 nuclear board F411E, whereas the compilation itself, if your current machine starts to generate the code for its own processor, then that's compilation. So that's your PC and laptop is the host compilation. The cross compilation is from the host compilation, you creating that machine code so that you can send that to the embedded target, whatever microcontroller you are using. In this case, we are learning STM32, but you can also use the same process in other microcontrollers. So that's what cross compilation is. And next we get into the cross compilation toolchain. The objective of the compiler is to generate machine code for the target machine. So that's why you need the cross compilation. And what is tool chains? The tool chains are the one they make it easier for the cross compilation to make the program run, and it checks all of that without any graphical representation. The tool chain or the cross compilation tool chain is a collection of binaries which allows you to have all of that, the compilation, the linker, and to assemble your applications. It also contains binaries, and so that you could use that to debug your application on the target, meaning your target board. It also helps you to analyze as well the executables, meaning if you run the program, it will help you to analyze what sections of it. And also when you talk in terms of analysis, this is the sections it will cover, to dissect different sections of the executables. From when you compile the program, it will help you to understand, make into sections what it is. And disassemble is the one which it converts from C language to assembly language programming. And the analysis or the cross compilation, the tool chain, will help you to extract symbol and size information. For example, the memory allocations, the flash memory and the RAM sizes. So that's what the analysis will do. And then they convert executable files from one format to other file formats. In general, you get it as the .elf format. .elf stands for executable linker format, and through the help of the tool chain, you can also convert the .elf format to bin format, a little Indian, or hex format. And also your compilation tool chains will provide you C standard libraries. But as I said earlier, you have to do everything on the command prompt window. You can't use the IDE to do it. Today the session is about the command prompt, not the IDE. So you will get to learn how you can compile the program in the command prompt, and how you're going to dissect the sections, and you're going to learn about how you can write your own sections. So I'm sure it is a very wonderful learning for you all today, because this is really an important topic when you get into the industry. When you work on complex projects, startup file really comes in. Really, it's out there. Okay. Still talking about the cross compilation tool chains, there are two popular tool chains. The most popular tool chains anyone goes for is the GNU tools. It's a GCC tool. GNU abbreviates to GNU, not Unix. It's for ARM embedded processor. It is a free and open source. All you have to do is just Google GNU, and you can download and start to use the compilation tool. But if you already have downloaded STM32 CubeIDE, the GNU tool is a built-in, so it will be there. If not, I'm going to show you now how to separately download that and install it. And the second one is the ARM CC from ARM Limited. Keel uses that. So this is a GCC, and the third one is a GCC GNU's compiler collection. So the ARM Keel version is a licensed version. It's a paid version. You need to pay to use it, but GNU tool GCC is free and open source, and that's what you're going to learn in this class today. So let's get in and learn, and I'll go to Google and I will type in online. I'm going Google, just one sec, and you have to type GCC for ARM in Google. You're going to type GCC for ARM and download from the first link, ARM embedded toolchain downloads. Click on that. So this is the GNU toolchain download, and for Windows version it's the 10.3-2021.10. As you can see, there is few releases. There is Windows .exe, and there is a Linux versions, and there is for Mac, for Apple. So you don't have to worry much into that. So I'm going to download the Windows version. Click on this, double click, will get you to download. So it's downloading. Once it downloads, you have to just go by the screen prompt, and you just click on next, and go and compile and finish it. I think I have already downloaded this earlier, so in my case you may be able to see the files that's previously in there. If not, I'll show you again how it's all you can download. The only thing is after you download this, the thing that you have to add is you need to set up your environment variables where you can use this GCC tool, the GNU toolchain. That will help you to do all the three: compilation, the linking, and the assembling of the code. Nearly done. I'll show you how. Another 10 seconds up there. Excuse me. Okay, so it's downloaded. I'm going to double click on the download link, as you can see from the bottom of the screen. This will start the download section, and it will start to run on the background. It's still loading. Still loading. It shows the blue circle, so yes, it's nearly there now. It's going to ask us to say hit yes. This is the user control you will get after you double click from ARM, so just click yes, and this will start the process with the setup of the GNU toolchain. It's running on the background. I will get it on this window once it's available. Okay, so this is how you'll get, you have to start with the installer language, set it as English, hit OK, and then the setup wizard will open. In this, just click next. This is just to say you're going to download GNU ARM embedded toolchain, the version 10.3-2021.10. So just click next and I agree, and this is the destination folder. By default it will live in program files cross 86 GNU ARM embedded toolchain, and just you don't have to change. By default it goes to that folder. Just install. This will extract all the files from the ARM site, and it will put everything into your computer under C drive under program files cross 86. Once it downloads, then you need to set up the environment variables, and that's complete. After you complete the environment variables, then you're good to go. Then you can use the command prompt to learn about the startup file. So I'll show you everything, so just be patient, and it's just about to finish. It's just halfway mark. In the meantime, just download all those reference manual and the data sheet and go through all the registers. So far what you have learned, like the exception model, what is exception, what is interrupt, and how you can do all of those things, and what is the architecture involved in the ARM Cortex M4, what are all the different registers. So this will come in handy, like you can come after you get familiar with a lot of things, and by completing the next 10 days you will get more in-depth knowledge, and you can start to write your own codes, and you can come up with your own unique projects, which all really helps in shaping up you to become a professional engineer very soon. Okay, so it's finished. By default the add path to environment variable won't be enabled. That's very important, so don't miss this opportunity. You have to set up your environment variable, so enable that. I'll leave this for a sec. It's unticked, so enable that to add path and then click finish. So this will open you with the command prompt and the readme file. So I will just minimize the readme files, and this is to say the tool chain, the GNU ARM embedded tool chain, and the version is downloaded, and this is the command prompt. By hitting finish you get automatically booted into a command prompt screen. Don't close this. You're going to use this to write your to check your GNU tool analysis. So minimize that, and now you're going to set up the environment variables. To do that, click on the search, and you got to type edit environment variables, edit the system environment variables. It's downloading on the background. I will show once the screen becomes available. So by default it comes into system properties. You need to click on environment variables and then click on path. You have to go, after you type in edit environment variables here, you need to double click on the environment variables. By default it goes into system properties and it's in advanced tab. The environment variables is under advanced tab. Click on the environment variables and you get the environment variables open. Click on the path and click on edit on the path. So already I have installed, and I put this GNU ARM embedded toolchain 10.2021.10.bin. This is what it would show. So 22.10 bin. So I already installed and it's already there, but if not, then you have to go to browse. You need to go to library, not library, sorry, you have to go to this PC and you need to go to C drive. C drive, yeah. You need to go to program files and you need to hit ARM GNU toolchain and go bin. You got to right click this, copy the location copy the location. You can do that either this way or just go by the folder. Just go to the folder, go to program files, go to ARM GNU, open this and click bin, and here right click and copy and come here, and you got to paste it. That's all you have to do. So GNU for ARM embedded toolchain 10.20.21, and this is the bin. You got to click here, right click, copy, and come here to this window, and you have to hit new, and then hit new, and then you have to hit paste. So that's the same as this ARM embedded toolchain 10, so you don't have to do this. Click OK, click OK, click OK, and all done. So the GNU GCC tool is ready. So in the command prompt that it's already opened, you need to see the directory now to see what directories you already have. So type in dir to get the directories. So these are all the directories, and you got ARM none EABI, that's what we are after, and we are inside the tool chain. So now you can see the bin to get the directories, binary directories. We are in binary, so get the directories again. So these are all the directories that we're going to use. Some of these directories. These are all the directories we're going to use. I'm going to maximize this, just one sec. I hope you can read it. So the one with the shows, these are all the binary executable lists. The one with -gcc.exe, that's the gcc.exe, arm-none-eabi-gcc.exe. This is the file that you're going to use it for compilation, linking, and assembly. And ld.exe, this is for the linker file. And object copy.exe, you have to use this to convert from .elf, the general format, to, if you want to say you want to use it in bin format or in hex format, this is the file you got to use. And read elf is to read all the elf files, and to analyze you have to use object dump.exe. This will help you to analyze the individual sections that's already in there. So we did all the environment variables now, so it's already set up and it's all good to go. So now let's go and see how this analyzing can be done using the prompt files. So this is the site. We already did this step by going into Google, and we typed these 2 steps, and we are up here. But if not, if you already downloaded this, then this by default you get that from the download. So these are all the steps that I would like you to follow. So follow the images from left to right to download GCC toolchain that I just showed you. And you need to go here if you use Microsoft Edge, and this is where you get to see the download on the top right. And then you come here to GNU toolchain, and this is to show you a different toolchain 12.2, but today we downloaded 10, version 10. and you'll get this message to click on yes. From ARM you have to click yes, and the next step is you have to set your English. Remember, the next step is to set English, and then you have to agree to the license agreement. Then start to click install. By default it goes to the program files destination folder, and you have to do just click install, and it will start to extract all the files as you saw already. I just got everything in there for your understanding. We downloaded toolchain 10. This is just an example to show you how to download toolchain 12, but if you follow the previous just few minutes back, yeah, that's how you have to do. You need to download 10 and click add path to environment variable. That's the important thing, don't miss that. And then once it's done, click finish, and this will automatically get you into command prompt and follow the next slide steps. And this is the steps that I already showed you, how to set up the environment variables. From here, if you see at the end fatal error, that means the compilation has already successfully set up the environment variables. And these are all some of the cross compilation binaries that you would like to use in your session today. So the arm-none-eabi-gcc.exe file will help you to do all these three: compilation, assembler, and linker. If you want to do an assembler, you need to use arm-none-eib-as for assembler. For linker, there is a separate session, it's coming up. You will learn about the linker scripts. And if you want to use the linker, you need to use arm-none-eabi-ld. And we're going to today learn about the analysis of the different sections. So you got to analyze ELF file analyzer by using this file arm-none-eabi-ob object dump. And these are all the analyzer file. And I already said to convert the ELF format to use it as a bin format or a hex format, you have to use obj copy, object copy. That's a format converter. Now let's move in to see what is build process with main compiler. As you already learned from the IDE, after you write the code, you go and save the program and right click on the project name and you hit the build project. So this is what happens after you hit the build project. This is what the compiler gives you. So the main object is when you hit that button to build the project, the main C program will start to compile and give you an object file. So that's the behavior or work for compiler to do. But this happens in 3-stage process. The first stage, the main.c program that from your source code, whatever you written, and that will convert as a pre-processing stage. This will convert to what is called main.i. The main.i is the preprocessor stage where it resolves all the directives, where it has all the hash include st standard input output.h, all the header files. So I'll just get into one of an example to show you how you could get this 3-stage process. Just bear with me one sec. You have to go to online GDB. Most of you may be familiar through your engineering degrees days. You need to go to onlinegdb.com. Once you go there and hit enter, there is a sample program which comes as a source code. So this source code you have to choose as C program and then follow what I am doing. So you have to go to settings. First select the language. So it comes with the language first. I'll click settings. Okay, first select as C program, because C program, this is a C program. Then on the settings, go to extra compilation flags. By clicking on by default your compiler won't show any of the intermediate files. So to do that, to alert your compiler to say that you need to see all your intermediate files to be generated, you need to specify that to your compiler, otherwise you won't get to see the different intermediate files. To do that, click on the extra compiler flags, click that, and then you need to type in dash save dash temps, save dash temps. This saves all the temporary files. So just click OK or enter. This starts to give you the temporary files. Just one sec. Once it finishes, then you have to hit run, and this will give you a temporary file. So it's saved, and click the run button. It's running, it's compiling the program. See the three. So this is the three processes that I explained to you in the build process. So as soon as you hit run, which means compile, the main.c program where you return your code #include with the preprocessor directives with the header file stdioh, it converts and it gives you all the intermediary files. Main.i is nothing but it's just an expansion to your main program, which has all the type definition, all the printf statements, all your scanf, etc. So for example, if you want to search for printf here, you will see the printf statements here in the eye of printf. So you got the printf statement. So likewise, you have all the internal and the external. So different. It's the expansion of your main program. So if you keep scrolling down to the end of the main.i, and this is where the main.c, your written program, lies in here. So from this, the compiler extracts, and it has given you all these files, which is the intermediate files that you don't know about, you don't have to worry about. So as soon as you compile, the compiler will do this job for you. So this is the main.i, and as you can see, you have written only a 10-line program in here, and that converts to nearly about 700 plus lines, nearly scroll down, so 737 lines, to be exact, about 742 lines. So that is the main.i. So once the main.i is happened, then your it gets into the second process, which is the main.i. The main.i takes the your expanded file, and it goes into another second stage called the code generation stage, and this is where the compiler now will change this code and give you a main.s. Main.s is nothing but, I'll show you what main.s in the online GDB. Coming to online GDB, main.s is nothing but your assembly language program for your main C. As soon as you hit the build, it changes to intermediate files to give you an expansion of the files, and then it changes to the same program. The C code is changed to an assembly language program. So this is all done built in. You don't have to do anything. All you have to do is build. I'm just walking you through about the different build process as soon as you hit the build. Okay. So the last stage in the build process is the assembly language. It takes and it goes to the assembler stage, and it compiles again and gives you an object file, and gives with the extension as main.o. Object files is nothing but it comes in the executable format. So this is the file you're going to load into the microcontroller board, into its memory, so that whatever you're going to write or what you have written, can be compiled and gives you the output. So that is what the main.o is. So the main.o will look something like this in the online GDB. If we go here, this is the executable linker file, so which it's a machine code which generated by the compiler, so we don't get to see much in here, but you will get to see some of it later, like .txt, .data, .bss. So this all divides into separate sections, and then it goes into the format of .elf. So this is the online GDB. Okay. So most commonly it will come as the .elf format. So for example, Texas Instruments and other microcontrollers, they may would like to use a different format, maybe hex format. So to do that, you need to use that copy batch in the ARM instead of instead of object dump for analysis. You have to use object copy. So you can convert from ELF format to hex or binary format. So let me show you an example to use the compilation tools. I'll show you an example how this can all be done with the tool chain that we just downloaded. So for that, I'm going to open IDE. Already I downloaded. I will open the project from the previous example, so I don't want to confuse you. Before doing that, I would like to go into the previous projects. I already made a copy of example 2. This is the source code with the main C. So just these three main, it has main C, syscall and sysmem.c by default. So this is where I'm going to create the files that you're going to use it in your project. So to do that, I'm going to bring the project in here. You can use IDE, or you can use generally Notepad or anything to write the program. So it's just a C program. So you're going to you don't need anything. Excuse me. Favorite. So I will go here to example. I need to open main.c. Main.c, right click. You can open with Notepad or click on Notepad. You just open that. I'm just showing you what that main program has on example 2 that we learned on that day. It's just opened in the extension window. I'm just dragging it here so you can see. So this is the program we written on the other day about the addition and the subtraction, if you remember. So this is the program we used on the other day. So I'll keep this. I'll copy this, come here. You can do Control C, or you can just right click copy and then go to the prompt, command prompt, and you got to change the directory path so that you can do these changes. CD, you have to go edit and paste. I'm sure I copied here. Right click, copy, come here, change directory, and then paste. Copy src, then hit enter. Is not recognized as an internal format. CCD. Okay, I changed it. We changed to the that's some glitch. So we are in the example 2 of that file. So I'll show you a small compilation to see what it has. So firstly I will start to see what the directories they have. So you got the main.c, you got syscalls, you got memc. So now you're going to use for this program to compile, so you're going to use that arm gcc.exe. so you got to type arm dash none dash where is it dash eabi dash gcc dot eabi dash gcc. Okay, so if you hit enter you will get a fatal error. So this is a good sign. If you see this fatal error, don't panic. That means it's just saying to us that the remember we did the environment variable setup, that it shows that it's properly set up with the tool chain, so you don't have to worry about fatal error. Is good. That means all the environment variables are set and you are good to go. So now I'm going to go in ahead and try to compile the main C program. So to do that you have to use arm dash the same files to execute, but I'm executing the main.c program. So gcc, I'm going to compile now. So to compile you need to include this -c argument and then type in main.c, and also you're going to want to see that in the executable format. So the argument is -0 and then main.o to see your output. So this gives the input from all the documents. What did I do wrong? gcc -c main.c -1 C for compilers. So if I did the directory, it should show main.c directory main.c. Okay, main.c, the directories are there, main.c, but the main.o is not generated. So I will just copy again, -.c main.o none EABI, sorry, it's my typo error, sorry guys. EABI dash GCC. Now compile arm none EABI minus GC. Now the argument for main.c, and you want to view the output, not 0, output as main.0 or O. So you hit that. Now the file is generated. You just wait, it's generating. Yeah, it's generated, and if you hit the directory, now the directory will be listed and you will see the main.o is created. So we successfully created the main.o file by doing this command to view the output. So this main.o, it's not target specific. It doesn't mean that it will run on that particular STM32, because to generate the machine code. When it generates for um, it doesn't target for one particular microcontroller, so it generates for different architecture. So now you have to go and generalize that for your STM32 with this series. To do that, you have to go to the to another side, but I think we are going a bit longer here, so I'll give you a bit of a break. So go and enjoy that break, and I'll see you in a couple of minutes, and I'll show you how now you can dissect these sections, and then I will help you and teach you how to write your own startup sections. So I'll see you in a couple of minutes. Catch you then.